right, I'm going to go ahead and get started. We want to appreciate your time that you're taking with us tonight. Thank you so much for joining us for tonight's webinar on structuring effective mathematics intervention in the secondary classroom. This is the fourth of our webinars in a series of webinars that we've held this fall. We had our first webinar on addressing unfinished learning in mathematics. And then our second webinar is focused on the unveiling of our resources on our Bridging for Math website. Last week's webinars focused on using small group instruction to help address unfinished learning in mathematics. All of those webinars were recorded and can be found on our mathematics website on the VDOE website. I'm joined here by the mathematics coordinator for K-12, Tina Mazzacane. She's the VDOE mathematics title. And we are really, really excited to have our special guest presenters help us with this topic because they are experts. Kateri Thunder has had the enormous pleasure of teaching math at every grade band from pre-K all the way through college. She also worked as a math specialist in Charlottesville City Public Schools and an assistant professor of math education at JMU. Currently, she's working with teachers and administrators across the Commonwealth and relishing every moment of crawling after her 10-month-old daughter, Anna, and talking social emotional learning with her school counselor husband, Adam. She is joined by John Almerode, who is also an associate professor of education at JMU. He works with pre-service teachers as well as in-service teachers across the Commonwealth. He's a dad to two Virginia public school learners, Tessa and Jackson, and a husband to Danielle, a fellow educator. John and his family live in Waynesboro, and they also have 3 Labrador retrievers. So I am going to stop talking and let them take over the show because they are going to give you some good information and entertainment this evening. Thank you so much, John and Kateri.
Hey, guys. It is so wonderful to be with you all. John and I were talking about how much we just love math educators. So getting to hang out with you all is just a thrill. So let's just dive in. Let's jump into our evening together. So our work tonight is learning about what works best in structuring effective math intervention. And we want to make sure we're using what works best so that we can amplify our impact on student learning, really maximize the time that we have with them and the planning and the thoughtfulness of our instructional strategies so that we can really move students forward. And all of that comes down to thinking about one question, a question that's going to just keep coming back throughout our evening. It's going to unite all of our thinking and really just be foundational for us. And that question is, where is the edge of their mathematics understanding? So this is the work that we do as educators. Every day in our classrooms, we're looking for the edge of our learners' mathematical understanding and trying to figure out exactly where that is so that we can jump in and move each learner forward from that spot. So we have 4 success criteria, 4 ways that we will know that we have figured out, learned, started to understand what works best in math intervention. Here they are. I can describe the process for implementing what works best in math teaching and learning. I can align interventions with the specific needs of my math learners. I can adapt those interventions to meet the diverse needs of my math learners, and I can evaluate my impact on math learning. So we really want to think about that question of where is that edge of understanding and use that to help us with that implementing, aligning interventions, adapting interventions, and evaluating.
So Kateri, I think for me, and we've talked about this before, I like to know the punchline before we dive into the weeds. And so what Kateri and I want to do is share with you the 3 big ideas that are going to drive our conversation this evening. So if you've got something to write with and something to write on, now would be the time to grab it. We're going to give you the 3 big ideas, the 3 big takeaways from this evening. And then we're going to go back and unpack each of them and pull back the multiple layers that are involved in that so that at the end of the day, we will know what to do on Tuesday. My first teaching job, my very first teaching job, I was hired to teach Algebra 1 Part 1A. Now, let me break that down a little more. This was when we thought it was a good thing to take a room full of learners that did not believe in themselves as math learners, and rather than have them take a course for one semester, we were going to break it up over 4 semesters. And instead of then telling them that it was to promote depth of learning, we just basically told them, and this is what the students informed me when I was hired, well, yeah, we're only supposed to get through 3 chapters this semester. And then next semester, we're going to do 3 more chapters. And so I walked in the door into a situation where they were very different than me. I was a math major. I thought everybody loved solving systems of equations using matrix algebra. I didn't understand why someone didn't calculate the possible permutations and combinations from their sock laundry drawer. There were certain things that just did not compute for me. And so how I approached mathematics was the exact opposite of how those 15-year-olds approached mathematics. And I didn't know what I needed to know to be successful. But we've come a long way. And so what Kateri and I want to do is look at 3 big ideas that, had I known then what we know now, it may have been a different outcome for them and for me. So the first one is a big one. One of the challenges I had in the classroom was I went in with a belief about what worked best in teaching and learning, but I forgot to include the most important part of that. And that is, where are they in their learning progression? And how does that inform what works best? Just because I taught differentiation that way, just because I taught trig identities this way, just because this is how I introduced logarithmic functions or rational expressions or calculating and finding the slope of a line this way today, doesn't necessarily mean that's what's going to work best tomorrow. Why? Because at the end of the day, our who comes before our do. Our who comes before the do. Who they are gives us insight into what works best. There's no one answer. There's no one fix. It's where are they in their learning progressions. The second big idea we're going to unpack this evening. We're going to peel back these layers. What works best not only depends on who's in front of me, where they are in their learning, but then what type of learning is going to happen next. Am I after conceptual learning? Am I after procedural learning? Or am I after the application of concepts, procedures, and thinking? That's going to help me decide what works best, because once again, what works best is not the same in every scenario or context. And so we're going to unpack in just a few moments what that tells us when we find out. Today, I want to focus on conceptual understanding. This is conceptually what a parabola is, or an ellipse is. Conic sections conceptually mean this. Or when I talk about what does it mean to use the where did the quadratic equation come from? Conceptually, what does it give me in my answers? That's going to be a very different approach than procedural versus application. Kateri's going to dive into that shortly. And here's the last one. The last one's a big one. We must constantly be evidence generators. In fact, in the chat, would you please put evidence generators? Evidence generators. Type that into the chat, get that documented so that we have that on the docket. Evidence generators. This is a new finding. This is something that's brand spanking new. Well, what we've uncovered in the pile of evidence-based practices is that those that are regularly above average in their impact on student learning are also those evidence-based practices that generate the most evidence for me as a teacher to interpret and use to decide where to go next. Let me give you an example. Note-taking versus summarizing. While note-taking does indeed have an above average effect size, it's nowhere near summarizing. What's the difference between the two? Well, note-taking only tells me what they wrote down, and it's likely what I asked them to write down. But summarizing tells me where they are in their own learning, and it gives me evidence that allows me to plan where to go next. The same thing goes with highlighting versus summarizing. So what's my point? The point is that knowing what works best requires that we constantly generate evidence. In other words, if we're not making their thinking visible, it's virtually impossible to know what works best because we have no idea what's going on in their brains. And as teenagers, that's a bit scary. That's a bit scary. So let's dive into this. So these are the three big ideas. I want you to take a moment and in the chat box, summarize those big ideas in your own words. We've got three of them. You've got them written down somewhere. If you would, take a moment in the chat box, in your own words, what are the three big ideas for this evening? I'll wait. Let's see what pops in the chat box. Harry heard more than three. So let's make sure we've got three. Number one, what works best depends on where our students are. What works best depends on the type of learning. And we must constantly monitor our impact. Yeah, who, not do. Good, 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 good. Where are the students? Where are they? Absolutely. Who, not do. Yep. Monitor impact. Absolutely. Yeah. And that's a big one. Make that thinking visible. Absolutely. So here we go. Let's dive into these. Let's talk about what works best and where students are in their thinking. Jody, I love that summary. Who, type, and evidence. That's a great way to do it. What works best in teaching the following things? So I'm going to put some ideas up, and I just want you to throw out some ideas on what you have found in your experience, in your classroom, with your expertise. What works best in, say, teaching the surface area and volume of three-dimensional objects, but focused on practical problems? What works best? What about helping learners figure out the difference or know the difference or understand the difference between permutations and combinations? What works best? Throw it in the chat box when you've got something. What about teaching systems of linear quadratic and quadratic equations, both algebraically and graphically? Well, that's a big one. That's a big one. What about the communication of ideas in mathematics? What works best in teaching that? And last and certainly not least, how do we help them learn that there are flexible, efficient, and accurate methods for computation? The big one there being flexible. What are some things that might show up in your strategy list? Jody, thanks for getting us started. Stephanie's got us going. Yep. Harry's good. Math talk. Yep. Real world examples. Math talks. Sliders on Desmos. Yeah, Desmos. Boy, we learned to love Desmos with COVID, didn't we? Seeing the change, having 3D models, hands-on. Yep. Rachel, I do, we do, you do. Rachel's bringing up something known as gradual release. Hey, Rachel, I want you to add a step. We want to add a step to that. It's some new research on this. I do, we do, and then add a cooperative learning component. Y'all do, depending on where you are in Virginia. Y'all do or you all do, and then finally you do independently. So Rachel, if you would add that third step, cooperative learning is the new component to gradual release. Excellent. Some great ideas showing up. Well, let's back up. Before we jump into any of this, so Desmos, concrete models, multiple representation, quiz reflections, Vanessa, quiz reflections is one of the strongest strategies we have out there. It's called practice testing, but I don't want to digress too far, but that's a great strategy. Before we dive into any of those, though, we have to ask our questions, or ask our question that we started with from Kateri. What is the edge of their understanding? Is a math talk gonna do it? Is a math workshop gonna do it? Is Desmos gonna be enough? And so it has to do with discovering the edge of their understanding. And so here are some things to keep in mind. When we wanna know their edge of understanding, we first have to know what those expectations are. And I'm gonna show you some research in just a moment that tells us we have a lot of power in what we think about what they can do as learners. And so expectations play a huge role in discovering the edge of understanding. And then we have to develop some kind of initial assessment or task. It doesn't have to be a multiple choice test that I give them at the front of the unit. That's not what we're talking about. We're talking about some kind of task that makes their thinking visible. Then we have to pay attention. And we have to really watch what they're up to and make sure that I'm noticing what they can do and what they have an opportunity to grow into next. And last and certainly not least, identify the gap. Now, I want to zero in on something. If you would, in the chat box, type in gap. Just type in gap, G-A-P, put it in the chat box, because I just want to get it out there. Oftentimes, when we say identify the gap, it often can lead us into deficit thinking. I want to say right up front now, that is not where Kateri and I are coming from. A gap in students' learning is an opportunity, not a deficit. A gap in students' mathematical understanding is an opportunity, not a deficit. Here's what I mean by that. And Margaret, here's what we mean by that. If there weren't gaps in their mathematics understanding, why are they sitting in our classes? So gaps aren't a bad thing. Gaps are a good thing because that's the opportunity for growth. And we need to find it so that we can be more efficient and more effective with our time. That's the key. And so gaps are opportunities for growth. They are not deficits. And Harry, that's another way to think about it. Job security. So let's start with some research. I want to share some research with you, and then I promise I'll hand it over to Kateri, and she's going to take us into a different direction with some mathematics. When it comes to expectations, I want to show you how important this is. I want to tell you a story about two groups of schools. A study was done in 2018 that looked at two different groups of schools. On the surface, these schools looked very much the same. Same demographics, the same makeup, where they were in terms of rural, urban, suburban. They were very similar. In fact, they were indistinguishable statistically when you looked at characteristics. Except one group continued to show incredible growth year in and year out. The other did not. If you've got two groups of schools that are statistically the same in terms of their characteristics, then what's the variable that separated the schools that showed growth from the schools that did not? It turns out it had to be with the expectations of the teachers. Take a look. The schools that did not show growth, this pile over here, 133 hours were spent on assignments that were not grade level appropriate. Let me translate that. Well, they're eighth graders, and last year was a complete train wreck. And so I'm going to have to go back, and before we even start on eighth grade work, we got to go and reteach all of seventh grade. Yikes. That's that group. Versus, okay, welcome to eighth grade. I have no idea what the edge of your understanding is because you weren't my students in seventh grade. So I need to find that out. But whatever I find out, we're going to be working on grade level right away. Turns out when that approach was taken, there's a significant difference in student growth, and growth precedes achievement. Here's another example. Students show up in my pre-calculus class. And yes, pre-calculus in many cases is algebra 3, but in pre-calculus, they walk into pre-calculus and I realize, wait a second, they were online all last year. What do? This research suggests and repeatedly shows, I'm going to show you another study later on, that pre-calculus should start with pre-calculus standards and then provide intervention and support where it's needed. The point being is that expectations matter. Expectations matter. When we believe students can learn and will learn from us, that has a greater impact on their learning than most other interventions or most other influences. So rule of thumb, first we got to know their edge of understanding, and then we have to get them to grade level work as soon as possible. As soon as possible. And we're going to come back to that, but I do want to give you a chance to kind of process this, because Kateri, you're going to talk to us a little bit about how to do this on the fly, because I don't have a lot of time in my math block to pause every little bit and issue an assessment and grade it. And then, I mean, what do I do with this?
That is really hard, right? Our instruction, we need to maximize. And so we're not going to stop instruction to assess, but we want to find out where is that edge of understanding while kids are engaged in their learning. So I'm certain that you all have some go-to things that you do. So observation is huge, right? Being able to talk with students, interview, confer with groups or pairs as they're working, and you're asking those questions, you're probing, you're engaging them in reflection, having them summarize. But one key of that is to actually document what you find out. You can also ask students to do the work, right, and record it themselves. That's another way to document it. We also learned so much last year about how to use all sorts of technology so that learners can show what they know, things like Flipgrid and Loom. So think about what are your go-to ways to find out in the moment, what do students understand? Where is their edge of understanding? What will be the next step for them? Here are some of my favorites for just having it with me all the time. I have a clipboard and I meet with students and talk with them as they're working on their problem-solving tasks. And I may have the one on the left that's just open. I just have a spot so I can record students' names, what they're working on, and what I discover. In advance, I record questions and our goals so that I can make sure I'm constantly thinking about that grade level work and what our goals are and how what I'm finding out is going to relate to those goals and relate to what we're trying to accomplish that day. I could also make a more specific way of observing and documenting, and that's the one on the right, where I'm really thinking, okay, here's our 4 things that we're going to do and know that we are successful doing today, our success criteria. And so I'm going to really take notes lined up exactly with those 4 success criteria so that then I can step back after the craziness of the day, right? And say, okay, here's what I heard, here's what I saw, here's what was explained to me, and what are the patterns that exist there? Where are places where, oh, I'm noticing as a class, we need to come back to this idea, or we're ready to move forward with this idea. And then also, I need to check in with these clumps of students or individual students, depending on where their edge of understanding is. So that's one place that we can document. And I really had to get that into my mind that I couldn't remember all of that, right? What I would remember are my perceptions of what happened. But when I document what kids are saying, when I just make that my habit, then I have that recorded and can refer back to it. Another thing that you can do to help really discover that edge of understanding is that task, right? Whatever the task is that you're having learners do, collecting it from them and really analyzing it. So even if it's a discussion, having some way that students are recording their talking and listening and understanding based on that discussion, that's really powerful. That's that example on the bottom right. Above it, you might just say, well, today we've been working on dividing fractions. Do you feel like you can divide fractions? Yes or no? And turn it in with the work that you have. Then you can see where are kids thinking they are, and also where's the evidence. How does that line up? Where can I find, okay, they think they can do this, but I'm noticing this misconception I need to address. On the far left is an example of an alternative way to engage in homework, right? So that idea of practice is really powerful. Also reflection and self-evaluation. So if this is our goal, mathematicians make numbers easier to work with when they can, and here's how we'll know when we're successful. And you can ask students to provide that evidence and even take a moment to reflect on something they were proud of from their work. And all of that can be a way to help us document and say, okay, here are patterns that I'm noticing to help me find those edges of understanding to move forward. Asking students, even in a really quick way, to drop their work, right? Something that they did from that day into a bin that's labeled to say, okay, how successful do you feel like you've been? How much mastery do you feel like you have? Or even popping a Post-it note up on that stoplight as they walk out the door to say, here, I'm doing great and continuing on. Here's my evidence. Or I'm stuck. Here's my question. And then have that work to help figure out, okay, now tomorrow, what am I going to do? Right? So really thinking about how can you discover where students are, where's their edge of understanding, but doing it within the moment while you're all together, while you have them thinking about the mathematics. How can you use it as an opportunity to really find out what do they understand and what are they wondering about next? That edge can also, besides finding out like exactly where it is, we can figure out what type of edge it is, what type of learning students are engaging in and ready for next. So it might be that they're ready for conceptual understanding. It might be that they're ready for procedural knowledge, or it might be that they're ready for some application. And we know that what works best has to align with that type of learning. So what we decide to do next depends on where students are in their understanding, if they're ready for conceptual understanding or procedural knowledge or application. And I'm sure, right, when we were math learners, I can remember this and feel this, right, that when I was learning a procedure, it felt really different than when I was learning a concept or when I was applying. And that feeling, right, that you have of like, ooh, that's frustrating or that is better, it is real, and it connects to, well, then as a teacher, you need to respond in a different way, right? When I'm learning a procedure, I'm going to, as a learner, need a different type of support, a different type of intervention to help me than I do with concepts or with application. And that can really help accelerate that learning and really help take that edge and move learners forward. So just to clarify, to make sure that we're kind of all on this same page about conceptual, procedural, and application, here's some examples just to get us all on the same page. So conceptual understanding, when you're looking to discover, let's see if my learners have that conceptual understanding, you're looking for, do they have the understanding of the meaning behind the mathematical practice or process? Can they make sense of those mathematical whys and relationships? So when you're working on systems of equations, this would just be, do they understand that concept, that a system of equations is that set of equations with the same unknowns? That's how they're related. And that similarity and that relationship is that concept that you're looking for. Procedural knowledge and fluency, that's the ability to select and use and transfer math procedures and problem solving, and then moving that work into fluency, right? So being able to fluently, efficiently, appropriately select those strategies and use them. So that would mean in our systems of equations unit, really being able to look at that systems of equation and have a procedure to understand, okay, here's how I graph linear equations, and here's why I would do that, because I'm looking for that intersection, which is the solution. And I'm building on that conceptual understanding of knowing, well, they're related because they have the same unknowns. So of course, when they intersect, that's the solution that I'm looking for. That's that relationship. Application is where you're moving to that authentic or new context, and you're taking all of that conceptual understanding, those procedures that you're fluent with, and you're applying them to something new. So for example, that might be making a decision about something where you have to use a system of linear equations to make sense of it. All right, so taking this all the way back to those big ideas, right? We are trying to discover what's the edge of our learners' understanding, and we want to be able to find what that is to match it with an intervention that will help all students move forward. And to do that, we really have to, in our discovery, think, okay, what's the conceptual understanding? Do they have that? What's the procedural knowledge that I'm looking for? Do they have that? What's the application of this? What would it look like to transfer that? Do they have that? And to see where exactly is the spot where I need to nudge forward? Where do I need to step in and have that intervention, that just-in-time intervention ready to meet students where they are and move them forward? And there are so many options that you all already shared, lots of things that work, right? But pairing what works with just the right time with the learner is the challenging part.
And so, Kateri, I want to jump in and answer a question that's popped in the chat box. It's one of my favorites. Harry, you've asked a really important question, and it's not part of tonight's show. So this is a commercial message brought to you by the Virginia Department of Education. The question is there an order here? And I think there are others that probably have that same question. So Harry, I appreciate you asking, and I'm sure there are others. Fania, you come in and say, and if I mispronounce that, I apologize, that timing is important. The answer is yes. But let's talk about, is there an order to procedural, conceptual, and application? Unfortunately, the answer is yes. Now, why do I say unfortunately the answer is yes? Because it's not what we as math people like. And I'm telling you that, Kateri, and jump in here, we don't like this, because we want to be able to say, all right, today we're learning about slope. Here's the equation for slope. Please make sure you can use this equation to find slope. Now let's go figure out what this means. And now let's go transfer it. It turns out when you ask the cognitive guys, when you get the cognitive guys and the cognitive girls to come on in and share their research, it turns out concept first increases the likelihood of transfer later. So if you just want them to solve equations like little robots, right? We know that we can make that happen. So Harry, your question's tough because is there an order here? Well, if all you want them to do is solve equations, then no. And you know this because they come out of, and oh, forgive me for this one. They come out of elementary school and they've been taught the algorithm, crisscross applesauce to get a common denominator, right? And then we ask them to do rational expressions and it falls apart. Why did it fall apart? Well, they were able to do the procedure successfully. But what we asked them to do with rational expressions, what we asked them to do with rational equations is we asked them to apply that concept. But if all they've come with is a procedure, the application isn't going to happen. So to answer your question, there is no order if your outcome is just one of those things. But if the goal is to transfer to new contexts or to use it, then yeah, there is an order. It's conceptual, procedural, and that then sparks the application. Here's another example, and then I'll leave it alone. Differentiation. If we taught them the shortcut rules right off the bat, if we didn't do limits first, then differentiation, then implicit differentiation, then integration, then related rates would be a disaster because related rates require conceptual understanding of everything before it. But if I just do the shortcut rules, I'm not going to be able to handle related rates. And so there's a calculus example, but there's also an additional example. So I don't mean to go down a rabbit hole, but I love that question. Now, you can use application first as a motivator. Of course, that's a great way to do that. That's often called an anchor problem, and Kateri is going to come back to anchor problems shortly. And yes, Joanne, this requires a motivation component. That's a great question. It can provide the hook, Ashley, but Joanne, you're right. Sometimes they just want to know the answer. We have to resist that. So let's do this. Let's go into breakout rooms. Kateri, I think my clock says it's time for a breakout room. What I want you to do is I want you to think about something you're going to teach tomorrow. And if you're, well, it's 6:30 at night. Forget that. Don't worry about tomorrow. That's set. Leave it alone. Let's go a farther day out, something that you can mess with. In your breakout rooms, I want you to pick a topic that you're going to be teaching Wednesday, Thursday, or Friday and beyond. And I want you to break it down with your colleagues into what are the concepts, what are the procedures, and am I asking them to apply it? In other words, let's start sorting this out so that we understand that there are different components. So I'm going to set up our breakout rooms. Welcome back. Welcome back. So that was a quick debrief to kind of talk through the concept or the idea of conceptual, procedural, and the application of learning. Now we need to do something with it. And so this is where we dive into aligning the type of learning with the intervention. And we're going to get into some specific interventions and how they align with this type of thinking. But to do this, though, we really have to draw on the expertise of my favorite educational philosopher and educational thinker, Kenny Rogers. It's the idea that, look, there are things in the evidence-based practice pile that in and of themselves are evidence-based practices. The research says that if you use these, that they are going to indeed provide an above average impact on student learning if implemented in the correct way or a way that's conducive to learning. But still, some of them are better for procedural learning. Some of them are better for conceptual understanding, and then some of them better for the application of thinking. In other words, when it comes to interventions, you've got to know when to hold them. You got to know when to fold them, right? You see where this is going. When John released this in 2016, he had no idea the impact it would have on American audiences. In Australia, this fell flat. Not only did they not care, but they were not entertained. In the US, this is a big deal because when you start talking about Kenny Rogers, there's a percentage of the population that starts to take it personally. So I think it works beautifully in this situation. So let me show you some interventions that are always on the evidence-based practice list. In other words, these are interventions that have an above average effect on student learning when implemented in a way that is appropriate and aligns with learning. So take a look at this. Some of these you're familiar with. Some of these you may not be familiar with. Some of them you didn't think they were really interventions, like self-questioning, but that's actually a specific learning strategy that we can directly teach students. Here they are, evidence-based practices. But on this list, there are those that are really powerful for procedural learning, and there are those that are really powerful for promoting conceptual understanding, and even better yet, there are those that are more supportive of application. So on your own, independently, you're going to have about 1 minute and 37 seconds to move through this list. And here's what I'd like you to do with that list. As you go through that list, I want you on your own. You can do it on some note paper. You can do it in your mind. It's totally up to you. Go through that list and decide, okay, direct instruction, procedural, conceptual, or application. Note-taking, procedural. You see what I'm doing? Take about 1 minute or so, 1:37 seconds, move through that list and decide where you think you get the biggest return on investment: conceptual learning, procedural learning, or the application of thinking. 1:37 seconds, just quickly move through that list. We'll talk about it in just a second. I'll keep a watch on the time. 1:37 seconds, go. About 30 seconds, move quickly through that list. It's not for a grade. We're not going to collect it. So let's see what we've got here. Now, one of the things about this list that I struggle with is that as a math teacher, it's often hard to take what the research says is an evidence-based practice and translate it into the mathematics classroom. So one of the challenges with this list is that it's outside of the math context. And so maybe if we put it in the math context, it might help us sort through this list. So that's what I want to do. I want to take that list and we're going to translate it into mathematics interventions. And these are things that we can do that will move the needle forward in terms of learning, but they're going to be in a specific context, right? So maybe I need a mini lesson on the unit circle because I've noticed the edge of their understanding is fill in the blank. What about note-taking about different approaches to solving quadratics, completing the square, the quadratic formula, graphing, factoring? Prayer might be one of those approaches. Summarizing the concept of absolute value, getting learners to talk through that. What is absolute value and why? What kind of values does it produce? And then how does that connect to the graph that you get from absolute value? Targeting specific mathematics language around things like, right? Things like trig identities and trig relationships and getting them to use the right terminology, permutations, combinations, those sorts of things. What about practice simplifying expressions with trig identities and spacing that out? Representing relationships between quadrilaterals. Now, my 7-year-old just had to do this, but of course, it's something that we do at a different level when we have geometry involved. Different approaches to solving systems of equations. We can use reciprocal teaching around that. Why did you choose this method? Why did you choose that method? Can you summarize the process? Those sorts of questions. What are the differences between those approaches? getting them to reflect on the reasonableness of their answer, similarities and differences, problem-solving teaching, narrating your approach, peer tutoring, and of course, then debating different approaches to problems. Some of those are conceptual, some of those are procedural, and some of those are indeed application. The trick being is that the selection of a strategy must align to the type of learning I want, the type of learning I'm after. The intervention matters, but it matters in its application or its implementation and not just a blanket answer. So when somebody says, well, what works best? You can't answer that with a single answer. It depends on two things. Where are they and what type of learning am I looking for here? But let's talk about one of the big things, right? And you're right, Harry, and many can be both or all three, which means I have to be careful about trying to silo these things, right? So peer tutoring may work if I need the tutor to help the individual being tutored practice rehearsing their use of language and describing using precise and accurate mathematical language. That may work there, but also peer tutoring can help in modeling problem-solving approaches. So now it's become procedural. Debating different approaches to problems could be conceptual or it could be application. They may debate the best way to tackle a particular problem. So you're right, we can't silo these. We have to make sure we know what it is we're trying to get to in our learning. There's another part of this that's important. And for this, we want to transition just a bit. The strategy I pick should be focused on moving learning forward, not remediating. And so one of the things we want to talk about is, do we use remediation or do we use acceleration? Which works best? Because one of the challenges in selecting the intervention with the type of learning has to do with our mindset. It has to do with our beliefs about student learning. And we've already talked about this when it came to expectations. It's going to come up again. And I want to spend just a few moments right here before we hand it over to Kateri to talk us through the answer to this question. So is it remediation or acceleration? When I pick them, what am I trying to do? By the way, what does the research say? There's a new research study that has just come out. We're going to look at it in just a moment. Which works best as an intervention? A remediation approach or an acceleration approach? In the chat box, which of these would you pick? Remediation or acceleration? In terms of interventions, which works best? So Stephanie, we won't go there. Yes, Angela, I love that approach. The answer in the research seems to be acceleration. How do we know? Well, there's a study that's just come out, and we've had a chance to look at it. It turns out that after the pandemic, it's acceleration. And there doesn't seem to be a lot of argument over this data at this point. Now, the studies are being done again and again and again to try to figure out how to sort this out. But it turns out that when classes were involved in acceleration, not remediation, right? Classes with learning acceleration, almost all of them returned to their pre-pandemic success. If they were remediated, they struggled much more this year. And their rate of struggle, you ready for this? Their rate of struggle was 10 times more than those receiving acceleration. Well, what's the point? And the point is that our focus should be on not just grade level expectations, but an intervention that pushes learning forward, And so when it comes to acceleration versus remediation, turns out acceleration is giving us our best return on investment, But I want to address what's in the chat box, because it doesn't mean, for those of you that said remediation, let's make sure we're talking about the same thing. Kateri is going to walk us through how this plays out, because it's not just acceleration as in stand in front of them, hose them down with information, go as fast as you can to make up any quote loss, or unfinished learning is the actual way to describe it. There wasn't any learning loss. Learning didn't just fall out of their pockets, but there is some unfinished learning. It's a certain type of acceleration, right, Kateri?
Yeah, it's not where you're just increase your pace, go faster, cover, right? Which is what I immediately think of when I hear acceleration. So if I had been asked that question, I previously would have said, well, remediate, because I'm not going to just skip over stuff with speed. But in our case, what we're talking about is acceleration of meeting students where they are and using the instructional strategies that maximize that time, which will accelerate learning. It will make that time the most impactful time for learning, right? So we just keep finding that spot, push forward, find the spot, push forward, find the spot, push forward. And we don't leave a day or a time of learning alone from doing that work. We're constantly discovering and we're constantly differentiating. And that's how we accelerate, right? Constantly finding where students are and moving them forward in that grade level work. So let's look a little bit at differentiation, just so, again, we're on the same page of what that means. So when you think about your mathematical task, right, you found where students are at the edge of their understanding. You know who's working with conceptual, procedural, application, but you're all still working together, right? You're all still working towards a common goal, and you have this rich math task, and you want to have that task that has a low floor and a high ceiling. And then you can adjust that task to make sure that it's meeting students where they are and pushing them forward to accelerate that learning. So you can take that task and change the content, the process, or the product. And the changes that you make can be based on learners' readiness or their interest. And then there's a whole host of ways that you can think about making those changes to help communicate the different options to students. And those are those instructional strategies. So let's break it down a little bit more, okay? Readiness. If you're going to change something based on readiness, it's because you've noticed that's where students' edge of understanding is related to the learning progression or the learning trajectory or the goals that you have set for the whole class, what we're learning today. You notice that kids are at different spots along that mastery. Their zone of proximal development is in a different spot. And so you're finding exactly that point and then moving forward. You can make adjustments to the task so that you can catch each one of those students wherever they are and help move them all towards that goal, which will accelerate their learning. You can also make adjustments based on interest. So you can do personal interest. You can take a task and make it fit what someone is personally interested in. There's a picture of a baseball stadium, and I adore baseball. I could watch baseball all day long. Anything with baseball, I am willing to engage in a conversation about. And so if you put baseball in it, I am in. You could also, though, because sometimes finding personal interest connections is really hard in math, right? You can also do some situational interest. So that means you present, here are some choices of tasks, choices of tools, choices of who to work with. And in this situation, here's what I'm going to choose. And that choice might be different. Sometimes I want to work alone. Sometimes I want to work with someone. Sometimes I want to draw something. Sometimes I want to build something. Sometimes I just want to write some equations down. And that is situational interest, where you allow for that choice. All right, then after you've thought about, okay, do I need to make adjustments based on readiness or interest, maybe both, then you're going to think of how to adjust your task. So you can adjust the content of your task, the process for engaging in that task, or the product of that task. So in content, that would mean, well, maybe you're adjusting the size of the numbers, the types of numbers that learners are using. Maybe they're using rational numbers. Maybe they're focusing on fractions or decimals because you've noticed what they need to practice with. You could also adjust the types of proportions students are using, the operations they're engaged with, types of transformations. Are they working with polygons, polyhedra, which type? What kinds of graphical representations do they need practice with, or do they need to build some concepts around? What kind of complexity for their algebraic expressions or equations? Maybe you're adjusting the complexity, giving less complex algebraic expressions or more complex. And then also the type of function. You can adjust that depending on wherever that area is, that is the edge of their understanding. You can also change the process. So sometimes students will be working with a partner that you assign or that they choose, or a group or alone. All of those are ways that you are differentiating. The materials, the resources, the scaffolds, the math tools that you provide as a choice or that you match carefully with the learner based on what they need to practice, based on what they need to explore further or try applying. That's a way to differentiate the process. And then the strategies is another way that you can change that process. What strategies are you either asking learners to try and practice or work on, or are they choosing to use? And then finally, you can adjust the product. That's what they're producing to show what they know. And there's lots of ways to do that. We often think about, well, are they going to talk through something? Are they going to draw something? They're going to build something, create something? Are they providing a written explanation, an oral explanation? What's happening there? All of those can be things that change to help that differentiation. And that is a way to intervene with students just in time. So some strategies, here are so many. When you think about your differentiation strategy, this is how you might want to organize your task, how you want to communicate that task to students. The thing that I really want to bring out from this conversation on differentiation strategies is that it's flexible, that it changes, right? So you all mentioned lots of things about like being hands-on at the beginning, that's a great strategy. Having really powerful questions is a great strategy. Having choice is a great strategy for learners, absolutely. The other thing to remember is that the way you're differentiating and the way you're having students work together a group, it has to be flexible. It has to be responsive to what you've discovered yesterday or the day before about where they are in their learning, because every single day they're learning something new, right? So you're not saying like, I'm keeping this group together for forever, but that you're adjusting. They've learned something new, and now the next day they may need a different intervention. Their edge of understanding has moved because of the learning that they did with you the previous day. All right, so let's watch that in action, because that's like a lot of things, right? And class is messier than that, right? It's not just streamlined of like, okay, well, I'm going to just do this one way of differentiating, but you might differentiate based on readiness and interest, and you might use multiple different strategies. So I want you to kind of see what it might look like. This is one high school math class, and they have a common goal. The common goal for everyone is that students are solving quadratic equations graphically and or algebraically. And they have, by looking at student work, looking at that discovery phase, right? The observation, documentation, student work, they've noticed, okay, I have some students who really need to come back to their edge of understanding is around graphical solutions for quadratic equations. And I have another group that needs to think about those algebraic solutions. And then I have another group who's ready to take, they've got that, right? And their edge of understanding is moving into the application, where they're taking both ways of solving quadratic equations and applying it. So let's see how this class organized the way they were going to differentiate, the way they were going to accelerate learning by meeting students exactly where they were and move them forward.
Mastering that content.
We started our unit on quadratics about a week ago, and over the last 2 days or so, we've looked at individually, specifically on what areas each student's been missing or having troubles and struggles with. We've seen them be successful with the small components of solving a quadratic. We've seen over the last couple of days doing our activities in class that they're getting bottled up in the length of the procedural side of things versus the independent components of it. So what we've planned today is to move forward and taking and focusing specifically on those areas of concern for each student based on the information we've gathered over the last couple of days. And students will be strong in one area but not the other. So that's how we divided up our groups today for the lesson.
We've been spending the last week or so on quadratics, right? We talked about graphing, talked about solving by factoring. But what you guys sometimes get confused or struggle with is the little pieces. So that's what the purpose of today's warm-up problem was. If you look back there, never did I ask you to solve the whole quadratic, right? Number 1, I asked you to solve a 2-step equation. Number 2 and 4, I just asked you to factor it. And number 3, I asked you to manipulate. Those are the 3 things you have to be able to do in order to solve a quadratic, either by graphing or by factoring, all right? So today's warm-up was focused on the pieces of the puzzle, not the whole puzzle.
when we break our groups up in, they're each going to be focused on a specific area of quadratic equations. Mr. Cohen's group is going to be on solving them and looking at what it means to actually factor and then solve down, and what do those actual answers represent when they're done with it. The group that will be working with our math tutor will be focusing on the representation of it graphically. What does it mean to actually have the parabola on the graph, and what do you look for those solutions? And then the group that I'll be working with today will be the extension application group. So we'll review those topics at the beginning and then take it to the next level to see how does this actually apply to the real world circumstances, and what does the parabola look like on the graph compared to real life, and see if there's a connection between the two.
Mr. Barrett.
All right, so you could hear that they are thinking really carefully, right, about where is each learner related to the goal, the grade level goal that they're all working towards. And in this case, the way they're going to differentiate is by having different groups, right, and thinking about the task through a different lens. But they're also thinking about what kind of learning the students are ready for and documenting where that is and how to move the learners forward. So they're matching that differentiation to accelerate learning, and they're also thinking about, well, what strategies will work? And so even those interventions that we talked about, right, like note-taking and summarizing and discussion, those you might apply differently in those groups depending on where students are, depending on what they're ready for. And this differentiation is really powerful. It's a way to think about how you can meet students where they are while still having that common goal across everyone. And then after this lesson, the next day, right, those groups may be different, or maybe those groups won't make sense, and a different way of differentiating will make more sense as the intervention to help move everyone forward. So thinking about how you're going to implement those interventions is really important.
So let's take a moment and pause and reflect back on this. So you've had a chance to hear about how interventions are supposed to accelerate, not remediate, but not accelerate as in put the pedal to the metal and drive it home. That's not going to work. Instead, we want to accelerate with differentiation. And what Kateri shared with you was an overview of how we can go about this through content, process, and product. We're going to slide back into breakout rooms for about 6 minutes, not a particularly long time, but for about 6 minutes for you to kind of think through that list you created earlier. You were asked earlier to develop a list of conceptual learning, procedural learning, and application. So you have that. Now go back to that and talk about how you might make adjustments to the content, to the processes, and to the products so that everybody's working towards the same expectations, grade level, but you were making adjustments so that it meets the needs of everyone in our classroom, regardless of what went on and what's unfinished. We meet them where they are and we make those adjustments. Hey, welcome back. Welcome back. We are in the home stretch. And so we want to just talk about a couple of additional things here to throw in. And yes, I apologize that my dogs have been good all day and we're down to this last block of time and they are losing their minds. And so I appreciate your patience. The only thing worse than that is if we use the word Siri or Hey Google or Alexa on a webinar and it triggers everybody's Alexa, you know how that goes. So let's talk about the last piece of this puzzle. What you noticed in that video clip and what you've noticed when we talk about acceleration with differentiation, it's not just the evidence-based practice that has to be the focus here. It's how we implement it. One of the struggles I had in the classroom when I was teaching out, whether it was Algebra 1, Algebra 2, pre-calculus, calculus, no matter what I was teaching, I struggled sometimes with the elements of implementation. I might have a strategy in place. I might have even mapped it out and planned to differentiate it, but I forgot to check one thing. In order to effectively structure our interventions, the whole purpose of this evening's webinar, there are things I need to have in place and keep a check on. Number one, does it align to those learning goals? Now, Harry, you brought this up earlier, and so we're going to go back and get it. You pointed out, Harry, that these could be used for one, sometimes two, sometimes all three. What determines that is not my favorite approach. One of the things that we talk about all the time, Kateri and I, along with Doug Fisher and Nancy Fry and John Hattie, when we work together, we talk about the fact that we should not privilege a strategy over student learning. In other words, just because it's my favorite way to do it doesn't mean that is how we choose or why we choose to implement it. So when we talk about implementation, fidelity to those learning goals, what is the learning goal? That means some of these can be used across all three. Harry is exactly correct. So when it comes to structuring our interventions, we have to also keep in mind an eye out for what are the learning goals. Are they clear? And is this strategy aligned to that learning goal? Here's an example. We can't talk to learners about dialoguing about mathematics and only provide interventions that are done independently and without conversation. That's a mismatch. Number two, this is my favorite. Are we given the necessary dosage? Or is it one of those things where, well, I went to this webinar with this guy by the name of John and this other person by the name Kateri, and they said if I did this, and so I did it on Tuesday, and they didn't know anything else on Wednesday that they didn't know. Hold on. The dosage matters. Is it something that I have to do every day for several weeks? Is it something I need to do once every other week? Is it something I only need to do at exactly the time that I need them to think about that particular procedure, concept, or application? Am I giving it the time to work? Is it the necessary dosage? Is it the necessary dosage? Am I making the adaptations that Kateri just shared with us? Am I adjusting the content, the process, and the product based on who my learners are? And last and certainly not least, when it comes to implementation, is this idea of the environment. Look, at the end of the day, are our structured interventions recognizing the role of equity and inclusion? Are we ensuring that students have the equity of access and opportunity to the highest level of learning possible? Are we ensuring that inclusion is the theme, that we are making sure all students are active participants, all students are valued members of the community, that any gap they have in learning is not a deficit, but an opportunity? And then are we providing the adaptations that give them the access they need? Let me go back to data I shared with you a while back. This is not always a yes answer, because the other piece of information that this research pointed out is that when it comes to remediation and acceleration, individuals that are in schools with a majority of students in color are more likely to be exposed to remediation. And the same thing goes for classrooms in Title I eligible schools. In other words, we are not offering equity in terms of acceleration over remediation. So the other part of implementation is, are we promoting a quality environment for that delivery? And the last thing I want to throw in there before we hand it over to Kateri to close us down is this. It's that third point. Remember, there were three main points that we wanted to get across, and we're down to that last one. We should be constantly generating evidence of learning, and we should constantly be looking to see, did that work? In other words, we step out and we find out. We take an intervention, we implement it, and then we constantly monitor to see what evidence is being gathered. We are evidence generators. Patricia Parker, you are 100% correct. We are evidence generators. And we can't just go in blindly. We have to plan for this. Do we go in knowing what we're looking for? Do we walk through the door and say, I'm using this intervention because I want to see that they can use mathematical language with accuracy and precision. I want to see that they can fill in whatever the blank is. The point being, do we go in planning for what we're looking for so we know if that intervention worked? Not only do we plan for evaluation, but as Patricia pointed out, as we generate evidence, are we interpreting it as it's happening? Are we making use of Kateri, what Kateri shared with us, those structures? Are we just writing it down so that we can have it in our grade books, so that we can have it available? So if the principal comes in, we can say, well, I gathered evidence. Or are we actually interpreting it? Wow. So what does this tell me? Is it tell me that their edge of understanding is procedural, their edge of understanding is conceptual, whatever the case may be? Are we interpreting that evidence? And last and certainly not least, are we using it to plan where to go next? Where to go next? That's the big one. Do I have that evidence and let it decide, or help me decide what I'm going to do next? In other words, It's not necessarily summative. It's not formative. It's informative. Michael Scriven, back in the 60s, when he developed the concept of formative and summative assessment, later on said, it is a waste of time to debate the two. That it's not so much the type of assessment we have, instead, it's how we use it. So whether it's formative or whether it's summative, nobody, who cares? Who cares? Instead, is it informative so that I know, did the intervention work and can I do it? If the intervention didn't work, what am I going to do instead? And that's the power of this. We can plan for gathering evidence by simply putting our success criteria on one side and jotting down the evidence we're looking for in the other. We can even make an effort to look at what they're doing, what they said, and what we're watching them write. There are lots of different ways to do this. And so the trick is, are we using assessment for informative purposes? Because we've got to know whether that intervention is working. And that's the final message. And Kateri, what have we missed? What else do we need to kind of talk about here when it comes to structuring those interventions? We've talked about differentiation, acceleration, equity. Let's start to wind this down. Our colleagues have been fantastic hanging in there with us. So I'm gonna hand it back to Kateri to close us out.
Yeah, I think the message I keep remembering is that when we're talking about intervention, we're not talking about that place where you're pulling kids out and putting them to work on some task, right? Or some concept or some procedure for some long period of time. We're talking about that just-in-time intervention where each day we're noticing where kids are, we're identifying it, and we're moving them forward in that instant. And that is the kind of growth that will accelerate. And all those decisions that we make around how we meet that need and how we structure that time, how we differentiate that work, that's going to help us not only know where the edge of math understanding is, but how to move them forward and how to do that in a really impactful way to maximize time.
Yeah, I think the other thing that is important, and I struggle with this, and I know our high school colleagues, I hope I'm not alone, maybe I am. The term intervention sometimes leads us to, I've got to fix them. No. They don't need fixing. Intervention in this case is, I'm going to step in, because that's my job as a teacher, and I'm going to take where they are and I'm going to accelerate them to the next level, whatever that level is. And so intervention just simply means I'm stepping in. That's my job as a teacher, is to intervene, but it's to intervene at the edge of their understanding and treat it as an opportunity, not as a deficit. Yeah, that was my only final thought. I'll hand it back to you.
No, it's beautiful, right? Because it is knowing where kids' strengths are, right? Valuing that, being willing to be surprised that, oh, well, that's where your misconception is. Okay, well, then we can address that, right? All right, so we did so much tonight, and you guys have been so fabulous with your questions and your ideas and your comments. So here are our success criteria, how we would know we learn it. Now, to say we've mastered this, John and I are not in a mastery place. So hopefully you feel yourself moving forward, right? But hopefully you feel like, yep, I can describe a process for implementing what works best in math teaching and learning. I can align interventions with the specific needs of my math learners. I can adapt interventions to meet diverse needs, and I can evaluate my impact. And that cycle is going to be so important that we keep doing, because of course, we're going to have kids out with quarantine. We're going to have subs coming in. We're going to have all sorts of things, right? The world of education is not staying the same. And so we need to make sure that we are in that moment when we're together, checking for understanding, listening to kids, making sure they're talking, sharing their ideas, and then using that to help us evaluate, was our teaching effective for their learning? And when we do that, regardless of all those things that are out of our control, we will be able to control what our next step is on the next day of instruction. Thank you so much for everything. Thank you for all your questions and comments. And yeah, Kristen, will you share about how to get the PowerPoints and all of that?
Yes. Thank you so much, John and Kateri. You did not disappoint. I think everyone was super excited to participate in your webinar, and you shared a lot of great information. And you also really supported one of our biggest messages in some of our other webinars, is that whole just-in-time intervention. That whatever you do in intervention, whether it's in the class time or a separate intervention period during the school day, it should always support that grade level learning. What can we do? What can we fold into that grade level learning? So the communication between the teacher and if there's a different interventionist is really key as well, to share all the information that you're learning in your classroom with your formative assessments and finding that edge of understanding if you have a separate person that's working on some intervention in a different time period during the day. But yes, thank you so much. We really, really appreciate it. And thank you everybody for joining us. The fact that you're here on what is today, Monday, from 6 to 7:30 in the evening shows your dedication to your students, and with the fact that everyone is very stressed out with this school year, and that you're doing this above your workday is just very amazing, and your students are very lucky to have you. We will be posting the recording on our webpage, hopefully in the next couple of weeks, and then we'll share the PowerPoint to the with the attendees. And I think that is pretty much it. So thank you again. I hope you all have a great rest of the evening and a great rest of the week. And we'll see you next time.